All right, one last problem for us to look at, and this does introduce a little bit of a new wrinkle here. Instead of just having an x squared, I've got a coefficient on my x squared term, and that does require that you do something just a little bit different. Before you go and match up your radical form, you will need to factor to get that coefficient off of the x squared. So I need to factor out a 4. And if I factor out a 4 from x squared, that's fine, but I do need to factor a 4 out of 49, and of course 4 is not a factor of 49. So I'm just going to write it as the fraction 49 over 4. And hopefully you can see if I were to distribute, I would just get minus 49 back. So now, when we go looking at a radical form, we have something of the form x squared in the front minus a constant at the end. X squared in the front minus a constant at the end, we are now looking at for the first time doing this substitution, a secant of t for x. My a value, do not worry about this 4 in front. Your a value squared is whatever is sitting after the subtraction sign. So my a squared is 49 over 4. Take the square root of the numerator and denominator, and you get 7 over 2. And this is going to work out just fine. Again, these trig substitutions are a little bit like magic because they take things that look really messy, and then all of a sudden it just gets better. So as we saw above, the substitution we're supposed to use is our a value times secant of t. And we automatically, after getting our substitution written down, are going to go ahead and take the dx of that, which will be, derivative is going to be 7 over 2. The derivative of secant, in case you don't remember it, is secant times tangent. Now go ahead and do the substitution for the x and the dx. So I've only substituted at this point, and I'm being very careful that I kept my 4 here. I've got some nice parentheses showing I still need to square both parts of this expression, and that's going to be the next thing that I do. And when I square 7 over 2, I get 49 over 4. So you can see the cool thing that happened here is it matches the constant at the end. So I'm going to go ahead and factor that out of both of these terms. And I still have this 4 here, not losing it. Next, I'm going to notice my good luck here. I have 4 and divided by 4. I can cancel those. So that just leaves me with square root of 49 in the front. So now my integral has a 7 over 2 in the numerator, secant t tangent t dt. And in the bottom, that square root of 49 is going to become 7. And I've got my radical ready for matching up to an identity. So going off to the side, I'm going to remember that it's tangent squared t plus 1 that equals secant squared t. I'm going to solve that identity so that it matches what's underneath my radical. So I'm going to subtract 1 on both sides, and tangent squared t equals secant squared t minus 1. I will do that substitution in my next step. And now these constants, we do need to do something here. So I'm going to take the 7 over 2, first of all, out in front. And then keep in mind the 7 is in the denominator of a fraction. So that's really the same as 1/7. So again, you can see magic's going to happen here. Those 7s are going to disappear, and really my constant's just going to be 1/2. I'm left with secant t tangent t in the numerator. And in the denominator, square root of a squared tangent just leaves tangent. So I cancel the things I can cancel, and I have now simplified the whole thing to 1/2 integral of secant t dt. So again, even though it looks really messy, it cleans up so nice, and that step right there just makes me happy. This is the same as 1/2 the natural log of the absolute value of secant of t plus tangent of t plus c. So I was able to integrate without having to do anything particularly fancy. The last thing, of course, is again, I need to make sure I have substitutions for each of these here. So I need to go to my right triangle, put in t. Now my x value here is 7 over 2 secant t. As we've seen many times, if we want to move this fraction, instead of dividing by it, we can multiply the other side by its reciprocal. So I'm going to have 2/7 with an x. And for making life simpler, you can opt to put the x at the end, but it's actually going to help us out to put it in the numerator. Those are equivalent. So that equals secant of t. Now, you have to remember what we said earlier about secant is a buddy of cosine, whereas cosine of t is adjacent over hypotenuse. Secant of t is hypotenuse over adjacent. So I'm going to label the hypotenuse 2x, the side adjacent to t, as 7. Do my Pythagorean theorem to find the missing side. And just be careful on when you put in the hypotenuse, do remember to square both parts of that. So you're really looking at 4x squared. Subtract the 49 over, you have b squared equals 4x squared minus 49. Last step, take the square root. So for my substitution for secant of t, I have this ready to go. And now I need tangent of t. Tangent is opposite and adjacent sides as a ratio. I forgot to put my opposite side on here. It's this 4x squared minus 49. So I do opposite, which is that expression, over the adjacent side, which is 7. And that gives me the other substitution that I need for my antiderivative. I'm going to substitute. And if it makes you happy, since these fractions inside have a common denominator all ready to go, you can combine that and just make that a single fraction. Not required, but again, this is where if you're checking answers against the back of the book, you may run into this notion of an equivalent form. I will always accept any form that is equivalent to what answer my key shows. Hopefully that's enough examples to get you rolling with this. The nice thing is the process really is similar every time. It's just you have to make decisions about how to evaluate your t integral once you get to that point. And again, it can be anything that we have learned that gets you through that step.